Four sides, same size, square shape, corner here, corner there, I can see a square. Square, square, four sides fair, square, square, everywhere. Count with me, 1, 2, 3, 4 square shapes all around for sure. La la la, square shapes. Window square, book so square, tile floor, picture frame, four sides standing straight and tall. Square shapes, I love them all. Square, square, four sides fair, square, square, everywhere. Count with me, 1, 2, 3, 4 square shapes all around for sure. La la la, square shapes. See the square, trace the square, fingers dancing in the air, side by side, all the same, playing square shape counting game. Four sides, stop, 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 stop. Square time, square time. Square, square, four sides fair, square, square, everywhere. Count with me, 1, 2, 3, 4 square shapes all around for sure. La la la, square shapes. Building blocks and sandwich bread, box of toys beside my bed, four corners meeting nice and neat. Square shapes make learning sweet. Square, square, four sides fair, square, square, everywhere. Count with me, 1, 2, 3, 4 square shapes all around for sure. La la la, square shapes. Four sides, same size, square shape, I can find them everywhere. Squares are all around to share. Square, squares.
Listen closely now to an ancient tale of the triangle, a shape that will prevail. Three sides, three angles, a simple perfect grace, a fundamental form holding beauty in its space. In geometry's wide realm, the triangle isn't alone, but part of a family beautifully shown. Meet equilateral, all sides perfectly matched, angles of 60 degrees, a harmony untouched. Then isosceles arrives, two sides a mirrored pair, while scaling stands unique with differences to share. By angles they also differ, each with its own song. Acute angle sings of sharpness where no angle goes wrong. Right angle stands firm with a perfect 90-degree hold, its legs and hypotenuse, a story brave and bold. And finally obtuse angle with a wide open embrace, an angle over 90 in time and space. Perimeter is its journey, traced by your own hand. Just sum its three sides, ABC. You see the path around its edges, and for the space it covers, half of its base. By its height you will multiply the surface it embraces as time goes by. So the triangle, a simple form with tales untold, a melody in geometry.
A rectangle is a flat shape with 4 sides, where opposite sides are equal in length. The most important feature of a rectangle is that all 4 of its corners are right angles, meaning they measure 90 degrees. A rectangle has 2 long sides and 2 short sides. The long sides are equal to each other, and the short sides are also equal. In addition, a rectangle has 2 diagonals, and these diagonals are equal in length. The diagonals connect opposite corners and pass through the center of the rectangle. Because of its regular structure, the rectangle is a common shape in both mathematics and daily life. For example, notebooks, books, phone screens, and tables are often rectangle. The area of a rectangle is found by multiplying the length of the long side by the short side. Its perimeter is calculated by adding 1 long side and 1 short side, then multiplying the result by 2. In this way, the rectangle is both a fundamental and important geometric shape.
A circle is a line that's curved just right. It loops around and stays so tight. It has a center right in the heart. From there, the radius makes a perfect start. The catch. Draw across the middle, side to side. That's the diameter in which we take pride. To find the circumference, don't go far. You see into HUHRE. Pi is about 314. It helps us learn and explore much more.
Prism's got a base that's a polygon shape. It stretches up, yeah, no time to wait. Is it slanted or straight? That's what we name. Right or oblique, not all look the same. Volume's easy, don't delay. VA times H, that's the way. A times H, remember today. Triangular base, it's a triangle prism. Hexagon base, then a hex prism system. If all sides match, we call it regular. Count the edges, it's getting familiar. A prism's full, it holds some space. Geometry rules, math's in its place. Top base, bottom base, parallel planes. If the sides are straight, right prism, we claim. Need the surface, don't stress the game. Surface area, 2 area, pH, that's the name.
A is base area. P is perimeter. H is height. Say it with plane.
A pyramid is a 3-dimensional geometric shape characterized by a polygonal base and triangular faces that converge at a single point called the apex. The specific name will appearance from its base. For instance, pyramid with a square base is known as a square pyramid, while one with a triangular base is a triangular pyramid, also referred to as a tetrahedron.
Key characteristics of a pyramid. Pyramid's base forms its bottom face, which is a polygon. It possesses multiple flat surfaces, including the base face and several triangular lateral faces. The lines where these faces meet are called edges. The points where edges intersect are known as vertices, encompassing both the vertices of the base. The singular apex at the very top. All triangular lateral faces converge. 2 crucial measurements for a pyramid are its height, which is the perpendicular distance from the apex to the center of the base, And its slant height representing the height of each triangular lateral face, measuring the midpoint of the base edge up to the apex. This can be expressed as volume equals 1/3 multiplied by the area of the base multiplied by the height. Total surface area of a pyramid found by adding the area of its base to the combined areas of its triangular lateral faces. The total surface area, which is the sum of the areas of just the triangular faces, can be calculated for a regular pyramid. Give pyramids direct look. Is specifically 1/2 of the perimeter of the base multiplied by for a regular. Pyramids are classified by their base shape, leading to various types such as triangular, square, rectangular, pentagonal, or hexagonal pyramids, and so on for any polygon. Famous real-world examples include the ancient Great Pyramids of Giza in Egypt, which are classic square pyramids. Additionally, certain tent designs and architectural features often adopt a pyramid shape.
Welcome to our exploration of the fascinating world of cylinders. A cylinder is a three-dimensional geometric shape defined by two parallel circular bases connected by a curved surface. This shape is prevalent in our daily lives, appearing in items such as cans, tubes, and pipes. Let R be the radius of the base and H be the height of the cylinder. The lateral area of a cylinder is the area of its curved surface. Excluding the top and bottom bases, imagine rolling the curved surface into a rectangle. Its length would be the circumference of this. And its width would be the height. So the lateral area is equal to product between circumference of the base and the height. The total area of a cylinder is the sum of its lateral area and the areas of its two circular bases. Each circular base has an area equal product between pi constant and the square power of radius. The volume of a cylinder is the space it occupies. It is calculated by multiplying the area of the base by the height. I see a cone, I see a cone, round at the bottom, pointy at the top. I see a cone, I see that won't drop. Cone, cone, spinning round. Cone, cone, what I found. Cone, cone, spinning round. Won't cone steer around. Won't cone, what I found. One flat circle, one sharp point. Cone, cone, let's count each joint. La la la, cone shape. Round and round the bottom goes. Up and up the point it shows. Cone, 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 party hats upon my head. Cone, 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 traffic cones of orange and red. I see a cone, I see a cone, I see a cone, I see a cone. Cone, cone, spinning round. One
point. I see a cone. I see a cone. Round at the bottom, pointy at the top. I see a cone. I see a cone. I'm not flat like a circle. No, am I? I'm round. I've got depth and I've got height. Rolling around feels just right. My center's here right in the middle. Radius goes out like a riddle. I'm a sphere, rolling here and there. Everywhere. No edges, no corners anywhere. Round and smooth, I'm perfectly fair. I'm a sphere, rolling without a care. My surface curves all around. No flat spots can be found. Every point is just the same. Distance from center's my claim to fame. I roll so smooth across the ground, the most perfect shape that can be found. I'm a sphere, rolling here and there. Everywhere. No edges, no corners anywhere. Round, smooth, I'm perfectly fair. I'm a sphere, rolling without a care. Orange like me, earth like me too. Soccer balls bounce, we're spheres through and through. We have volume, we have space. Formulas help measure our place. La la la, rolling free, round and round. Can't you see? Perfect shape, that's me. I'm a sphere, rolling here and there. Everywhere. No edges, no corners anywhere. Round and smooth, I'm perfectly fair. I'm a sphere, rolling without a care. 3 dimensions, that's my way. La la, sphere's the word. Hooray!
Hello everyone. Today we are learning about the cube. A cube is a three-dimensional shape with 6 square faces. It has 6 faces, 12 edges, and 8 vertices. All of its edges are equal in length. To find the surface area of a cube, we multiply the area of one face by 6. To find its volume, we multiply the length of one edge by itself 3 times. Some examples of cubes in our daily life are a Rubik's Cube or a small gift box. Now, let's try drawing a cube together.
Sit in the back row, third seat from the wall, watching chalk dust settle while the teacher calls on everyone but me, hiding in my square, measuring the distance between here and there. 6 sides to every story I can't tell, 4 walls around the thoughts I know too well. I'm living in corners, angles so neat, perfect dimensions, but I can't compete with all the round edges, the curves that they make. I'm sharp where it matters, but something might break. Something might break. la 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 la, right angles. I'm living in corners, angles so neat, perfect dimensions, but I can't compete with all the round edges, the curves that they made. I'm sharp where it matters, but something might break. Something might break. I sit in the back row, thirsty from the wall.
Lines connect in perfect ways, oh, building patterns in my head. Every corner sharp and clean, yeah, counting sides until the end. La la la, round and round, oh oh oh, can't break down. Perfect shapes, perfect lies, nothing real between the lines. Started drawing on the wall, measuring each perfect edge. Neighbors think I've lost my mind, yeah, standing on this narrow ledge. La la la, round and round, oh oh oh, can't break down. Perfect shapes, perfect lies, nothing real between the lines. 3 sides, 4 sides, 5 and more, building cages on the floor. 6 sides, 7, counting up. When is perfect not enough? Paper cutouts on my desk, oh, every angle tells the truth. What I thought would set me free, yeah, just became another proof. La la la, round and round, oh oh oh, can't break down. Perfect shapes, perfect lies, nothing real between the lines. Oh oh wow, perfect shapes, la la la, no escape. First comes the square, simple and clean. 4 equal sides, angles all meet. Area, easy, it's no big ride. Multiply one side by the other side. Rectangle next, now take a glance. Too short, too long, it's a balance. To find the area, here's the trick. Multiply the lengths by the width real quick. Parallelogram tilts but holds its form. Opposite sides in the perfect norm. Area comes with the classic might. Multiply the base by the height. Rhombus is cool with sides the same, but angles change, still wins the game. To find its area, don't be confused. Multiply both diagonals, then divide by 2. Trapezoid leans, not all sides match. 2 are parallel, that's its catch. For area, here's what you do. Add both bases, multiply by height, then divide by 2. 4-sided shapes, all moving in time, learning their rules through rhythm and rhyme. From square to trapezoid, rhombus too. Area's easy when it sings with you. So grab your pen, don't miss the clue. Geometry's fun, yes, that's true.